Hey everyone, this is the fourth and final video of the introductory part in our traffic engineering CE432. Here we were talking about different transportation modes and characteristics. So as you can see here, it's the chapter 2 in our textbook, and when I say the textbook, I'm talking about the 5th edition of the traffic engineering textbook. So let's start. So this part just tries to summarize some of the tables and the numbers that we can see and the statistics that we can see in the textbook that uses different numbers of crashes, different number of vehicles, different number of capacities of different transportation modes. So the first one talks about different types of modes of traffic transportation. When I talk here about the difference between intercity and intracity transportation, and then we talked about a little bit about statistics here. We're talking here about some mileage of different public transportation lines in different parts of the world, and we talk here about also public roads and highways, railroad. We're talking about pipelines, channels, and also airports, and also the mileage of each used here in the United States. Also, when you talk about free transportation and everything that carries goods in free throughout the country. So these are the tonnage. Tonnage is 1,000 kilograms of freight, whatever, between truck, rail, water, air, and other different modes. And also we talk here about packages and mail, pipelines, and some other types of ways to transfer tonnage of freight. Free transportation is a part by itself of transportation engineering. It's one own discipline, and it's an amazing discipline where we talk about how to move goods from one place to another, and it's a very interesting part of transportation engineering. Now we talk about passengers here. How many people are traveled every single day? So here these are the passenger miles of travel, not every single day, I'm sorry, in the whole year of 2014. How many passengers were traveled throughout the whole year between different highway, public transportation, and other means of transportation. And then we talked about all kinds of modes that we can use. How is mode being classified in terms of type of service, lengths, speed, and different restrictions, and what are the goods and bads of each mode. So we talk here about walking, cycling, automobile, public transportation. We have different kinds of public transportation, starting from the slowest and easiest and cheapest, which is the local bus, and going down to what we call here the commuter rail, or the intercity rail, the rail that carries passengers in a commuter way between different suburbans and urban areas. Each one serves a different role, serves a different route, is expensive or cheap, and has a specific speed. You can see that the speed goes up once we go down this table. We talked about this table a lot, and we solved questions with regard to vehicle and person capacity, given that we have two different assumptions. First assumption is that we have here 1.3, sorry, here, let me just put a pointer so I can highlight whatever I want here. So here we have 1.3 person per car, or 1.5 people or persons per car. These are assumptions. We can have more, we can have less, based on some traffic engineering strategies that increase the capacity, increase the occupancy of how many people inside the car. And we have two types of flow: when we have freeways, or when we have uninterrupted. Uninterrupted means that we have freeways, there's no interruption whatsoever. When I'm talking about interruptions, I'm talking about signals, stop signs, access to services. So in a freeway you don't have that, you have controlled access. So this is called uninterrupted flow. And the second one is interrupted flow, and we have signals. You can see here the capacity goes significantly down because the speed goes down. And we have something new, we're going to talk about this in the traffic engineering class, is the percentage of green time in a traffic signal to the whole cycle, and we're going to be talking about this in detail. Also, when we have different occupancies, 1.3 and 1.5, then this is where we can increase the number of people in the car, and from that we can increase the capacity. But you can still see the capacity is a little bit lower than the uninterrupted, and that's very logic because of the high speeds. Let me just change my pointer options here to have a pen. So here we have some examples. Examples of capacities of different types of public transportation throughout North America, starting from when you talk here rail, we talk here something called rapid transit. In other words, this is what we call subways. So, well, the best example for subways, we have subways in different cities, but New York is probably considered one of the most efficient throughout the city, where it carries thousands and thousands of people every single hour, not every single day. And you can see here the number of people carried in each line in the subway in New York. We talk here about the commuter rail. We have different parts of commuter rail. The closest to where we live here in the East Coast is Washington, D.C. There's commuter rail that connects the city where everybody's working, especially federal workers, to the surrounding suburban areas. So you can see here the number of commuters going every single morning back and forth towards the city. When we talk about light rail, and we call it LRT, light rail transit. It's smaller than the heavy rail that you have up there. It's we can give you different names. Some people call it metro, some other people call it streetcar, some other people call it tram. We have different names for that, and we have an example in Boston, and in there is a South Line in Canada, in Alberta, in the city of Calgary in Alberta. So we have here, even we have one line, but you can see how many people this LRT can carry every single hour. Again, this is per hour. Finally, we have different buses, and we have two types of buses. We have something called BRT, bus rapid transit, where we have exclusive lane or exclusive route, meaning that we have this route specifically used for buses and sometimes service vehicles, but it's mainly used for buses. You cannot drive throughout these routes. So example here, definitely New York, Ottawa, and Ottawa had a project. I just want to talk a little bit about Ottawa because I worked on that project. Ottawa had a project in 2013. Sorry, yes, it started in 2010 and it ended in 2013, and it started construction. I think it finished last year, where they had a transfer from something called BRT. They had a complete bus route, and they moved towards an LRT because it's beautiful, it's more efficient, it's energy saving, and so it has different nice things to it. So when it was a BRT, you can see here how many people it carried per hour to the city of Ottawa. Again, so Ottawa is like Washington, D.C. It's the capital of Canada, and there are tons of federal workers working in the city every single day. Definitely New York also, we have different, these are bus lanes, so that's BRT, so this is BRT, BRT, BRT. When you have mixed traffic, so that's an example here of regular bus or feeder bus. We have different names for it, which is the least number of vehicles. So we can here again, because we can have a whole network with that, so still we can have thousands of passengers per hour. However, this is the less efficient type of public transportation, but still it's very accessible, serves neighborhoods. And these are the different public transportation things in the United States or in North America. So for you guys as a traffic engineer, we do different things. Definitely the first thing is safety, but also we're gonna handle congestion, And again, we look at the demand instead of adding capacity. How can we serve this demand? How can we make it work better? Then we do something called growth management, and this is with work with the transportation engineer. How can we induce or force the growth in different parts of the city so we can have less traffic problems? And also a big part of our work as traffic engineers that when we have construction or reconstruction of roads, how can we have plans of diverging traffic throughout the project? So these are the three different, you can say, projects that you guys, if you work as a traffic engineers, that you might be faced. Lots of congestion work, how to do growth management, and some also road reconstruction and work during construction in the city. So by this we end chapter 2 of this book, and the part where we talk about modes. In earlier versions of the book is just chapter 1. I usually ask my students to read this chapter. It's very interesting, it's very easy, it's an easy read in that. And by this, guys, thank you so much for listening to this video. I'm gonna have a next video which talks now more about traffic engineering, the user, the driver, the road. And see you soon in the next video. Thank you.